Hey guys, so today we're going to talk about polar graphs and their functions. So polar graphs are usually used to graph equations that would be more complicated if you did it on a usual coordinate plane, so we're going to use this plane instead. And today there's going to be about 4 different points that we're going to go through involving polar graphs. So plotting points on the polar plane is different than plotting points on the Cartesian plane. So points here are written in the form of rho, comma, theta. And over on the graph, the rho corresponds to how far you go out, whereas the theta obviously corresponds to the angle at which you go out. So first, let's look at the point 2, 135 degrees. That will go at the marked point right here. Wow, that was loud. Because you go out to the 135 degrees portion of the graph, and then you go 2 units onto that row of the degree. And that's basically how any point will work if both numbers are positive. Now for something like the point -3, 3 pi over 2, that's a bit different because if you'll see here, you would go out to the 3 pi over 2 line, which is 270 degrees, so you go here, except for it says -3. So what you're going to end up doing is you're going to go opposite what you would already. So yeah, so go down to this line here, and then see how it's like this is where it would be if it were 3, 3 pi over 2. But then you're going to go around, and it's actually going to end up being at the 90-degree angle instead. Now, -1, negative pi over 4 is even more different because both of them are negative. So first, let's go to the negative pi over 4 bit. So negative pi over 4, as we know, would correspond to 7 pi over 4 in positive coordinates, and that would be at the 315 degree portion. So we're going to go here. Except for it says that the rho is -1. So instead of going here, we're going to go here instead. And those are the 3 types of points that you will most likely encounter. So next we're going to convert polar coordinates into rectangular coordinates using these 3 equations here. X squared plus y squared equals rho squared, y equals rho times sine of theta, and x equals rho times cosine of theta. Just a note, if you see, if you see that r, or rather that rho is equal to r or anything, then they're the same thing. They're just written differently. So let's start off with the point 2, 3 pi over 2. So what you're going to do, you're going to plug those coordinates into these equations here. So we know that polar coordinates are in the form rho theta. So here it's just a matter of plugging things in. So here we have that x would equal 2 times the cosine of 3 pi over 2. And then y would equal 2 times the sine of 3 pi over 2. Now 3 pi over 2 is located at the 270 degree place, which would be down here. So the cosine is 0, so x coordinate will be 0, because 2 times 0 is obviously 0. And then the sine of 3 pi over 2 is -1, so y equals -2. And then your new coordinates, your rectangular coordinates, are 0, -2. And so next we're going to practice converting rectangular coordinates into polar coordinates. So we're going to start off with the point -1, square root of 3. Now for this, you kind of want to know which quadrant the point's going to be in so you can get an accurate reading for an angle. So once you plot this normally, then you can see that it's in the second quadrant. And so first we're going to want to find the rho. So we know from before that the row squared equals x squared plus y squared. So to find the row, let's just do row equals the square root of x squared plus y squared. And then row equals -1 squared plus the square root of 3 squared. Bring it up here. Row equals square root of 4. Obviously then row would be equal to 2. And so next we have to find the value of theta. So we're going to use the equation tangent of theta equals y over x, because tangent of theta is opposite over adjacent, which in terms of this coordinate here would be x, or rather y over x. So we're going to do tangent of theta equals square root of 3 over -1, tangent theta equals negative square root of 3. Sorry, I can't write on this. And we know that the radian measure in the second quadrant with it a tangent value of negative square root of 3 is 2 pi over 3, or 120 degrees. So your final point conversion would be 2 and then 2 pi over 3. Although I'm pretty sure that Glennon likes it as 2 comma the angle, so we're just going to go 2 comma 120 degrees. So that's your final there. So next we're going to convert equations to and from rectangular and polar coordinates. So let's start with x minus 1 quantity squared plus y squared equals 1. We're going to plug in polar values for the x's and y's. So x becomes rho times the cosine of theta. So this becomes rho cosine theta minus 1 quantity squared plus rho sine of theta quantity squared equals 1. So that becomes rho squared cosine squared of theta minus 2 times rho times cosine of theta plus 1. Then plus rho squared sine squared theta equals 1. Now the 1's drop out. Then let's regroup. So rho squared cosine squared theta plus rho squared sine squared theta equals 2 rho cosine theta. Now you can factor out the rho squared. So that becomes rho squared times cosine squared theta plus sine squared theta equals 2 rho cosine theta. We know that the cosine squared of theta plus the sine squared of theta is just 1, so that just becomes rho squared equals 2 rho cosine theta divided through by rho. Rho equals 2 cosine of theta, which is decidedly simpler than the first equation that we started with. And so next we're going to try it the other way. So let's start with rho equals -6 cosine theta. So let's multiply through by rho to get rho squared equals -6 rho cosine theta. Rho squared becomes x squared plus y squared equals -6 times x. Becomes x squared plus 6x plus y squared equals 0. Sorry, that should be 0. Factor. So x squared plus 6x becomes x plus 3 quantity squared plus y squared equals 9, because when we did this part we added a 9. So the final is x plus 3 squared quantity squared plus y squared equals 9. Now, the graphs of polar equations are quite varied, so honestly, I would just do my best to memorize the shapes that come with each type of equation, because it'll make it easier. So you don't have to, like, test for symmetry, because many of these graphs have, well, they need lots and lots of points to actually show their actual shape. So I would just memorize these, but I'll show you a few just in case. So this is a basic setup for a basic type of graph. So basically you're just going to plug in the values of theta into a rho equals 4 times the cosine of theta. So these would be the points for that equation. Excuse the handwriting, it's just that this Explain Everything is not the best writing tool. So when you plot these, sorry, forgot to put the letters, can't do that, get minus 10 points for that. Okay, so the first point in terms of rho theta is 4 0, so that's at 0 degrees and it's 4 out. So 1, 2, 3, 4. That's here. So once you plot all the points, that's basically what it's gonna look like. I don't know why it's all black because this app won't let me make it clear, but yeah, that's the basic shape. And that will be the basic shape for anything rho equals, k times cosine of theta. When it's k, say if it was rho equals k sine of theta, then your circle would be the same. It would just be, oriented up and down. So like either here or here versus, this part and here. Excellent drawing skills. So one set of polar graphs are called Lima whatevers, and they're in the form of rho equals a plus or minus b cosine theta, or rho equals a plus or minus b sine of theta. So if a over b is less than 1, then the shape of it will be, like a circle, but it's going to have an inner loop. If a over b equals 1, I'll just do a continuous, then it'll be a thing called a cardioid, so it's heart-shaped like this. If a over b is greater than 1 but less than 2, then it'll be dimpled with no inner loop. So it's kind of like the cardioid, but it's like kind of like slight. Wow, that's terrible. And then if a over b is greater than or equal to 2, then it'll have no loop or a dimple. So it's kind of like an ellipse, but like it still pushes out more on one side. So it's like that. Generally, it's a very bad drawing. Now, I'm not going to go into a huge detail with the rest of them, but just know that, yes, there are circles, there are Lima whatevers, and then there's also ones with, rose petals. So here's an example of one. It'll go like this, with variation on the number of petals. So that would be, this is rho equals a sine of 2 theta. There's also these shapes called lemniscates. I think that's how you say it. And it's basically like this. So it's half of a rose. So it just goes like that. It's like a tilted 8. And that would be, that's rho squared equals a squared sine of 2 theta. So squaring it just eliminates part of the rose. Your lemniscate can also go in this direction as well. Now the rose is a bit odder because it depends on how many times the theta is being multiplied. So just keep in mind that if it's, so say that it's, rho equals a sine or cosine of n theta, the amount of petals that the rose will have, if n is even, so n is even, it will have 2n petals. But if n is odd, then it will have n petals. So here, n is 2, and if you multiply that by 2, you get 4, so it has 4 petals. And that's pretty much all you need to know about polar graphs.